Welcome to my geometry final project. I chose to explain congruent triangles for the topic of my project. So let's start off with triangles. Triangles, as we know, have 3 sides and 3 angles. And these angles, all 3 of them must add up to 180 degrees or it wouldn't be a triangle. The exact length of segments and measures of the angle defines the triangle and are important when talking about congruence. Congruence is most often defined as compatible, and in geometry, for a shape to be considered congruent, it must meet some criteria. Congruent shapes must be perfectly equal in size and in shape. This means that the segments or sides of the shape must all be equal in length. This applies to the measures of the angles, which also must be equal. We can look at 2 shapes and tell whether or not they are congruent by using something called isometry. Isometry, also known as congruent transformation, is a rigid transformation, or a mapping technique that uses sliding, flipping, and turning, or translation, rotation, and reflection to transform shapes. If we can transform or overlay one shape over the other perfectly with no overlap, then we know that these shapes are congruent. And we have to remember that we can't change the size of the shape. So even though that these have, well, it looks like they have equal angles and sides, they're not the same size. We can see overlap. We could also use triangle congruence theorems to prove congruence. And here are 5 theorems that can be used to prove the congruence between shapes. Remember that the order of these matter. So first we have SSS, or side, side, side. And that requires 3 pairs of corresponding congruent sides. And then SAS, which is side angle side, requires a pair of corresponding congruent sides, then corresponding congruent angles, then another set of corresponding congruent sides. Angle side angle, or requires a pair of corresponding congruent angles, then corresponding congruent sides, and then corresponding congruent angles again. AAS, or angle angle side, requires 2 consecutive pairs of corresponding congruent angles and a pair of corresponding congruent sides. HL, or hypotenuse leg, requires both the hypotenuses and a set of legs to be corresponding and congruent. There's also other postulates that can't prove congruence, such as angle side side and angle angle angle. Angle 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 doesn't work most of the time because we do not know this. We don't know if the sides are congruent because we only know the angles. So it could be a different size and still have the same angles. And then angle side side doesn't work because we don't know the angle between the 2 congruent sides. So we could ultimately just shorten it and it would still be the same thing. And that's why it doesn't work. And thank you.